We're online. Oh, I added you guys to the modern physics folder on Google Drive, probably, unless I forgot. But I'm pretty sure I did. Micah, I need your email, actually. Micah, give me your email.
Can't do simple multiplication. I really hope that doesn't affect everything else.
Type in your email.
Would you like me to tell you the answers to the homework?
Yeah.
Yes.
Okay.
Yeah, that was a little bit sad.
Okay. Alright.
I need it done.
I need a light.
Okay, here are the answers. Number 1 is 8.4 years. That's okay, good. Every now and then we do long homework. Number 2 is all the front of one decimal place. I think there should be so 3.6 light years. Number 3 is 7.3 years.
Oh.
7.275. Number 4 is D. Number 5 is 0.9798 C. I don't have an exact one.
What was that? 0.978?
0.9798. Pretty fast. Number 6 is 10.4 seconds. Number 7 is D. Number 8 is A. Number 9 is 28.6 meters. And number 10 is, if you kept it in terms of C, it would be 40.8 over C meters, or if you work it out in seconds, it's 1.36 times 10 to the negative 7 seconds. And the answer to the challenge is, if you like exact form, 2 root 3 plus root 15 all over 4 light seconds, or if you prefer 1.83 light seconds. And then the velocity is the same number, except with C instead of light seconds. All right,
What was the answer to number 9 again?
Number 9 is 28.6 meters. Okay, questions?
Can you discuss the challenge problem?
Of course not, Micah. Don't be ridiculous.
Jimbo and Jimbo? That's pretty good.
Given number 9, there are 2 different ways to do number 10. This is important because on a test, you can use this fact to cross-check. Okay? You can do number 10. You can do number 10 with it asking for how long on time, right? So that means you could do it with the time dilation, right? This is the one where she's jumping over something. Is this the high jumper? Yeah. Okay, look at it's a high jumper. And so she jumps fast. The bar is 40 meters from the ground. So in the Earth reference frame, you're going to have 40 meters. She's jumping this way at 0.7 c, right? And so in the Earth reference frame, how much time does it take? You don't have to reduce. Good. 40 meters over 0.7 c, right? Okay. Good. Let's reduce a little bit. 400 over 7. And we'll keep those units there for the moment. Okay. Okay, good. That's the Earth reference frame, so that won't be the correct answer. The answer asks for how fast it is in Guadalupe's reference frame, right? So then you'd want to switch it to Guadalupe's reference frame, where here she's the one who's moving. This is her. She's on her side because she's high jumping. Apparently she's no longer on her side. So she's like this, and now here she's basically, in this reference frame, she's lying down, and the high jump bars are moving, right? That's her reference frame. And so now this is going at 0.7 c. Okay? So the big question is, out of these two, which one has the proper time. And to answer that, you first have to consider what are the two events that we're measuring the time between.
We're jumping and we're hitting the ball.
Leaving the ground, reaching the top, right? Okay? So in which reference frame do those two events happen in the same location? Guadalupe's reference frame. So that means Guadalupe has the proper time, right? Okay? The rest of this is, therefore, so that this one is T. So the rest of this now is just a little bit of algebra, right? Gamma for 0.7c is 1 over 1 minus, and I would do 7/10 c squared. It's just easier that way. The c squared will cancel. They always do. 1 minus 49 over 100, and that's going to give you 10 over root 51. Skipping a few steps there, but you should be able to do that one. Right? Yeah, okay. And then, therefore, to find the answer, we know that this is our general time dilation equation. So, but now this is the one I want. T is the one I know. So Tp equals T over gamma, and T is 400 over 7 meters over c divided by gamma, same as times reciprocal. Right? And we can cancel that a little bit. And now you just have to plug it into a calculator. Okay, so that's one way of doing this. And you get 40 over 7 root 51 meters, and then you have to divide it by c factor there, which of course you can just plug in on a calculator. Or if you were doing this, if you did not have a calculator, you could leave it like this and it would be fine. Okay, so that's one way of doing it. You use time dilation to find the answer. But there's another way you can do this problem. What's the other way you can do this problem? Right. You could also, so I did this problem by calculating the time in the Earth's reference frame and then changing it to a new reference frame. The other thing I can do is to calculate the length in Guadalupe's reference frame and then calculate the time in her frame. Okay? Obviously, you should get the same answer. We can check very briefly because we already found that the length in her reference frame, Guadalupe's reference frame, is the proper length over gamma, which is to say 40 meters over gamma, so times root 51 over 10. Divided by gamma is the same as times reciprocal, right? Which is 4 root 51 meters is the length in Guadalupe's reference frame. Then, the time in her reference frame, therefore, is to find the time, you just take the distance divided by the speed. So it's going to be 4 root 51 meters divided by 0.7c, which you'll see gives you 40 over 7 root 51 meters over c. Same answer, what it should be. This one, you'll notice was faster, which happens sometimes, but they both give the same answer. Right? So you don't have to do both ways, but one can be a cross-check for the other. The key is this. You don't need to do a time dilation and a length contraction. That is not necessary, almost never necessary, in fact, right? You need to do one of them to get in the right reference frame. Once you're in the right once you have the quantities in the right reference frame, then you just use rate times time equals distance, right? So it's just a matter of getting all your quantities into the same reference frame, then you use perfectly normal, ordinary classical physics to find your answers from there. And that's a general rule. Most problems only have one transformation to do to get a number into the reference frame. Then the rest is normal physics. There's a few exceptions, sometimes you have to do too. But you don't just go around trying to time dilate and length contract everything you see, right? You usually just have to do one quantity and then just use normal physics. Okay? And by the way, I like to draw pictures. I think drawing pictures is really helpful. I do it all the time, and I encourage you to do it as well on physics problems. I find it helpful. Okay, good. Other questions on the homework? Go ahead.
For number 2, I somehow got the answer in kilometers, but I gave it in light years.
Very, very important. Thank you. Let's face it, meters and kilometers are stupid units when you're dealing with the speed of light. Because a kilometer is nothing to the beam of light, and a meter is even as a thousandth of nothing. And so it's a stupid quantity to use. So we if we're going to use seconds, which is also kind of dumb, but anyway, if you're going to use seconds, we use a unit of length that at least makes some kind of sense that like a second, a second per speed of light for that particle is a very, very long distance at that time, right? So what we usually use is things like the light year or the light second. You can do other things too if you want. These are the more common ones. What's a light year?
Distance that light travel.
Good. Well, this distance that light can travel in a year, right? Now, let's actually figure out what 1 light year is. How far can light travel in a year? This is not hard. It's the distance light travels in a year, right? And so you can calculate the distance by doing what? I'm pretty sure you said velocity times time, right? That's how you find the distance. So you do velocity times time. So velocity is c, time is 1 year. That's a light year, right? For a light second, similarly, you gotta guess c times 1 second, right? Okay, here's the trick. Whenever you see light year, light second, write it like this, okay? Because you see, this c is a real factor of c. That is, it can cancel out with other c's, and usually it does, okay? So, on the particular problem, let me take a quick look. You didn't kilometers, so you just convert it. Well, okay, for this particular problem, you can just keep it in light years and you never have to touch the units. But like, for example, if you have a velocity of 0.5 c and a distance of 5 light seconds, right? The time it takes to go that far is distance divided by the velocity, which is 5 light seconds divided by 0.5 c, and then the c's cancel out, and you get an answer that is in seconds. You see that? So we use light seconds. I love light seconds. They're so much better than meters. They're just natural units, and the reason they're natural is because you get the c's to cancel out, right? And so whenever you see light seconds, light years, just write it as c times second, c times years. And often you'll be able to get the c's to cancel. Okay? For that one, for number 2, you may have like converted or something like that and then converted back. It's not necessary to do that. The length attraction formula is gap is a unitless factor, so it can apply to any unit you need to touch in. Okay. Other questions from Omar? Yes?
For number 9, can you just go back over what this is
Right. Let me mention that. Sorry for the little bait and switch, by the way, on the quiz, but I really didn't think it didn't work out very sensibly. I basically have to start a whole new unit, or not like a next subunit, and then go back and do the quiz, and then I don't like doing that. I like it when you can do it when you just finish something, take the quiz on it, and move on. I prefer that. So they work better. I don't have that much more to say here. We'll do some practice today. But the proper length means you measure the reference frame where the endpoints of the thing you're measuring are stationary, okay? Which is much easier than proper time. Proper time is a little bit tricky. Proper length is really simple. It's just whenever the thing isn't moving, right? So here you're measuring the length of the distance from the ground to the what's that called? Bar? The bar, right? Yeah, right. You raise the bar, right? Okay. So in which reference frame are the ground and the bar not moving? The Earth's reference frame, the ground and the bar are not moving. So that's it. That's proper length. Okay? So proper length is substantially easier. Just think about the things you're measuring the distance between, and if they're not moving, that's proper length. Then you're set. Sir. What a great and very important question. Proper length and proper time. Okay, remember first of all, the word proper does not mean correct. Does not impugn any kind of moral claim on the. I do that. There's nothing special about the proper length of the proper time. Oh, you're looking so. You're what? Oh, you're just sitting in? Sure, why not?
We have so much room. If you bring your own chair. So something about proper length, proper time are not they're not better, they're not right.
okay? They are just convenient points to look at. That's it, okay? And as a result, they are different points because one's about time and one's about length. As a result, knowing the proper length, knowing which reference frame is the proper length tells you nothing about the proper time, and vice versa. They're independent of each other. So you may have a problem where your proper length and proper time would be in the same reference frame, they may be in different reference frames. There's no general rule about them. You have to consider them independent of each other. Does that make sense? So you have to consider the proper time when you need it, consider the proper length when you need it. If you know the proper time, that doesn't tell you anything about proper length, and vice versa. Okay? Good. More questions? Yeah. The quiz tomorrow. Okay, a few things. Wait, are we done with the homework? I will be happy to talk about the quiz on Monday. Yeah.
In comparison to the...
Sure. Okay, so the distance between the Earth and Proxima Centauri, and that's the Earth, which is a star, Proxima Centauri, which is a star. The distance between those is 4.2 light years. Just notice I wrote it like that, right? Now it says what's the distance between the Nijimbo's reference frame. So this is what it looks like. This is in the star's reference frame, if you like, right? They're not moving. In Jimbo's reference frame, it looks like this. Okay. And how fast are you going again? 0.5 c? Okay. So here, the stars are moving at 0.5 c. Okay, good. We're talking about the distance between these two stars. In which reference frame is the proper length? The proper length? No, wrong. Let's try again. Which one's the proper length? The first one, because the stars are not moving. We want to know the distance between the stars. They're not moving, right? So this is the reference frame of the proper length. You may notice this is the one with the proper time. That wasn't the question, right? So this is the reference frame of the proper length. The proper length, therefore, equals 4.2 light years. Gamma is going to be 1 over the square root of 1. Oh, we did this one yesterday, or whatever, right?
Yeah.
So it's 2 over root 3, right?
It's 50.
Right. So, because of this, we can say length equals proper length divided by gamma, and that means 4.2 light years divided by 2 over root 3, which means, 2.1 times root 3 light years, basically. Okay. That's important because I didn't get to cover length track. Things take longer in this class than in more game. That's how it is, sort of inertia. So I go faster in the other class. But that's okay because if you can ask the question, that's why I'm here. Otherwise, you get the internet. Okay, you good with the homework?
Yeah.
All right, good. Now let's talk about the quiz. So first of all, this is for taking quizzes. So tomorrow, let us meet in SI Bio, which is free at this time. Not every day, but tomorrow is. So let's meet at SI Bio, then we can expand into the 2 rooms, the lab and the main room, and actually have enough space to move your elbows when you're taking the quiz. Because I know you guys like to move your elbows when you take quizzes. So, yes.
Will calculators be allowed in the quiz?
No calculators or any other devices are allowed in my quizzes.
Gosh,
so bring a pencil. Maybe 2. Yeah. If you gave me the square root of 0.51, you would not get full credit for that problem. I would expect that to be reduced to the square root of 51 over 10. But it's not a huge deal. Like, if you're like, I don't have time to simplify all this, that's okay. The bulk of the points, as it should be, is on the physics, the physics part of it. But if you make an arithmetic error and I can find it, then that's fine. That's good. Like you'll get most of it. Yeah. Yeah. That was good. The entire class here for quizzes. Sometimes people want it, sometimes people don't. But either way, you'll have it. Yeah.
I guess with the analytics and with the up-line system, so what would you think, the homework you give us and what
homework we give you is a mix of levels 1 and 2. Because you've seen it on the homework, anything that is virtually identical to a homework problem is probably going to be level 1, right? Because you've just done it, right? So that's basically memorization. It's not quite memorization, but I think that's the lowest skill there, right? Level 2 usually means something close to a homework problem, but maybe with a small twist, right? Or something that's a little different from what you've seen before that require you to think a bit about it. Level 3 means a big twist. I don't know. Means you'll have to apply more. I just try and find a hard problem. I do my best. As always, as with SI physics, the big question is how do you prepare for level 3s? And the answer is, okay, I can't give you the level 3 in advance, right? You can't prepare by doing the same type of problem because the whole point is to be a different type of problem, right? So the best way is to understand why you are doing all the steps you do and think about what would be different if something changed. And you're like, well, what changed? Well, I'm sorry, that's up to you to figure out, right? But you can try and think about what did Dr. Dom do to try and screw you up. That's my job, yeah?
Well, you put up more problems tonight for practice.
I don't have more problems tonight for practice. I don't think it's actually that necessary, but we will have something we'll go over today that will add some more practice, yeah.
Are the questions all like computational, I guess, or are they like conceptual?
I sometimes give conceptual questions, but at this phase I'm going to be focused more on the computational. I have nothing against conceptual questions. It's supposed to be computational. The relativity unit, most questions will be computational. Yeah. Oh, you have a ball? No. The way they almost all my quizzes work, I have 3 level 1 problems, 2 level 2s, and 1 level 3. The quiz. Oh, and the top of the quiz is important. It's just time dilation and length contraction. No Galilean stuff. The Galilean stuff is just introduction, right? I mean, it's not what we're interested in, right? Because we're going into, right? So no Galilean stuff, no 4 vectors. We'll get to that, don't worry. But nothing non-relativistic. Everything is going to be relativistic. The whole test is time dilation, length contraction. Actually, not very much to study more, right? We will get back to the transformations and the 4 vectors, but we're going to do that relativistically, right? And so that won't be till later. Okay, so it's going to, the whole class period is going to be in SI Bio, please, because then we have a little more room. And are there any other questions about the quiz thing? Yeah.
Do you have like an average of how long?
That's interesting. It depends very much on you, but at this phase, people would have plenty of time. In some of the later quizzes, when things get rougher, sometimes people run out of time. You'd always have enough time. For me to do the problems to write out takes under 5 minutes. So you have enough time. That's not exactly what it is, right? It's the question, do you have enough time to figure out what's going on and how to do it? So that is, this quiz I could probably do in like 2 minutes. This one is very little computation, right? So the hard part is not the actual computation. It's figuring out what to do. As far as that goes, I don't know, you'll just have to see. This first quiz is not bad. I don't think you'll have a problem with it. People got perfect scores on it and stuff, or at least they did last year. And remember, there's always a redemption quiz. By the end of the relativity unit, I predict that you will find this quiz easy in retrospect. How about that? Yeah? The redemption quiz just gives you a chance to make back some of your points for each of the quizzes you've already taken. Usually, I think we have 3 quizzes scheduled for this unit. We have 3 quizzes, and then the end of the redemption quiz, you can make some of those points back as needed. Not all of them, but some of them. So at least you can salvage a field trainer.
Thinking probably after lunch.
And I mean, come on, we all have trainers for lunch. That's fine. Okay, any other questions on the quiz?
It's going to be fun.
It's going to be fun, always.
For Dr. Dom.
Quizzes are always fun. Ask anyone who's taken my class. I see what you mean. You said fun for us or for you.
I already made
So the quiz is always fun for someone. No, I would not, you should go study first. I do not think you should freak out. I don't think it's good use of your time, but you should go study, prepare best you can. And as with all such things, you don't really know until you do it. Once you see the first quiz, you'll have a good idea of how my quizzes work, and then you'll have, an idea of how you can prepare best I can tell you. Okay. And of course, go ahead and tell your friends in the other class that I give different quiz forms, so they can't do that one. So, ready?
Yeah.
Okay. So, I want to talk a little bit more about length contraction. It's not length contraction like working it out is easier actually than time dilation. I think it's easier to visualize length than it is to visualize time. But they're actually two sides of the same thing. But what's the proper length of this thing?
Space time.
Meter. So when it's stationary, its length is 1 meter. Now, if I run by you at top speed, yep, this is top speed, then what happens? It's like, by you?
It shrinks.
It is shorter, right? Now, let's imagine you can actually see something as it moves by at very high relativistic speeds, okay? See how like the numbers and the tick marks on it?
Yeah.
So what happens to that? So does it like shorten this way so now it stops at 80? No, it's not good. What happens?
They hit
It
close
squishes
edges.
everything together. Good. What happens to the height of the ruler?
It was the same.
Good. It stays the same. We can show that, but we actually, in a sense, we already did. We actually already assumed it in our other ones, but you can show
Yeah.
this. The length contraction only happens in the direction of the velocity. In this way, it's not moving, so there's no length contraction, right? This actually should not be too surprising. Yes, sir.
What if it's rotating? The object is rotating.
We are not going there. Rotation is acceleration, and therefore violates the basic idea of special relativity, which is about inertial reference frames. Rotating frame is not inertial.
Okay.
So it's not that there's no answer, it's that we're not going there. I will mention rotating reference frames briefly at the end of this.
Won't be fun.
It will be fun.
Oh.
So that everything gets squished together, like when you take something in PowerPoint and you drag the corner of the handle of it so it gets all weird and distorted. That's exactly what happened actually, exactly like that. It's not for the same reason, but it is actually the exact same effect. It just squishes everything equally, which means, let's suppose Matt is in a spaceship made of crystal as usual. You can see inside. There's no privacy for him. And now Matt goes by, and Matt is, what's she be doing? Dancing. Okay? So Matt is dancing. Now, as he goes by and you watch Matt dancing, which might not be what you wanted to see. Anyway, you watch Matt dancing, you should notice two unusual effects. What would you see about Matt while he's dancing? See two good, Ethan?
He's all contorted and weird because he's
That's specifically how's he contorted. He is
squished inward.
good, so he looks extra
Thin.
what?
Thin.
Thin. I thought you said pale. Okay.
He does.
Normally, all right. So,
Very slow.
no, so he looks extra skinny, right? And not in a normal, healthy way, but in a weird, like Photoshop way, right?
What's the normal?
Like he would look. Now his height, assuming his dance was the kind of kept him upright, his height would be still the same, right? But he would be skinnier as a result. And what would be the other thing we see that would be weird? He would be, that might not be weird depending, I haven't seen that dance, but no, but it's not just offbeat, it would be, it'd be slow, right? That's time dilation at work, right? Time dilation means because he's in a different reference frame, so he's dancing at normal speed, then we would see, if we watch it, we see it moving slowly, right? And that's everything moving slowly, so it would be just like, what digital effect? Slow motion. It would be exactly like slow motion. You just take all the processes and stretch out the time between them, right? So if he was doing jumping jacks, then they would be slow jumping jacks, but he would spend a lot of time off the ground, right? It would be everything just slowed down, okay? So this is the basics of relativistic effects. Time dilation, length contraction. As you can see, they're weird, right? But it does mean if you move really fast, you can convince people that you're skinny and slow. So the velocity doesn't change, right? It's the things that happen in the reference frame that change, right? Which means, what does a cross-country runner running at relativistic speeds look like?
No longer a cross-country runner.
How do they run?
Slow.
They look.
They move very quickly, but their feet move very slowly. Yeah, right. Interesting. Yeah. All right. So, also no skating. Okay. So, let's do this. I want some practice. Here's the thing. Yes, Benji.
How do they look? How do we look to the person who's doing it? Surprise.
What an interesting question. Well, let's just take Matt again. Okay, Matt is dancing, and he is dancing perfectly normally. Right now, who is right, us or Matt?
Both. Nobody.
No, not we don't know, but neither or both, depending. Right? Right. There is no such thing as one of them being right, which means there's no way to lock down on who sees who slower. So what does Matt see when he watches us dancing?
Well, if he's dancing slow, he should see everyone else moving fast.
No.
We would all be like much faster than. No.
What? We would all be moving slower.
Lies.
Oh, because to him we're moving.
Right. He's stationary, we're moving, right? So we would all be moving slower, and we would all be skating.
Okay.
You're like, wait a minute, that doesn't seem like it should work. Haha, and now the real fun begins. But before we get into that, which will dominate a large part of this unit because it's a little tricky, as you can imagine, something seems like that shouldn't work, right?
Yeah.
Okay, but you might not be able to put your finger on it yet. Don't worry, we'll spend plenty of time putting our fingers on it. But here's the thing: to prepare for the quiz and also understand our knowledge of relativity, which is the important part, right? Right. So, there's only one thing that's hard about these problems, right? And what's that? Good. Figuring out proper time, which one's the proper time, and which one's the proper length. So really, you don't need to do very much calculation practice. That's not the hard part, right? The only thing you need to practice is recognizing which is the proper time, which is the proper length. Remembering that those can be different in different, it sort of depends on the question, right? So what I have for you is a little worksheet. Take your computers out. You don't have to, I'm not collecting this. You can write the answers on your computer, on a piece of paper, wherever you like. Just to keep track of them, I'll give you the answers. But there's a series of problems on there that just ask about proper time, proper length, and using that information. Does whoever see the time shorter or longer? Whoever see the thing shorter or longer, right? Where the answer can change depending on which is proper time, proper length. So go ahead and work on this problem. You know, I wrote this worksheet a long time ago. I really need to update it slightly. Anyway, I think we'll figure it out. So it's under practice. You see it? Probably practice like that? Yeah.
Yep.
Well, on Moodle, if for any reason you don't have your computer handy, and this one I encourage you to talk to one another by all means. Don't do it during the quiz.
Okay.
Right now you can definitely talk to
Every one of them is C.
Or you can do it yourself and figure and compare answers.
That is
whatever you want to do.
Are you sure you're looking at the right thing? What? Are you sure you're looking at the right thing?
I think he was joking.
The document's opening right now. Oh, okay. Every one of them is C. That's the easiest.
Are they multiple choice? Oh, that's beautiful.
Oh, wonderful.
They're not multiple choice.
A, B, C, and D. Yeah.
Okay, read what they say though, Micah. Yeah.
That's painful.
That makes me cry on the inside.
That's right.
He just manipulated our emotions and feelings.
Like when he did the thing with the quiz, I think
So it's relatively
The thing I did with the quiz, or the thing he did with the quiz.
he did.
Just no. Relative to whoever was speaking.
I don't want. Oh my heck.
The heck? I hate you.
I hate
I
myself.
really forgot the definition of proper time.
Yeah, how do you determine proper
Proper
time?
time's the shortest.
I have a
Length the
Google.
longest.
I
And it's
Googled.
just proper time is
I wouldn't open this.
the time times gamma. Proper length is the length times gamma.
I know proper length.
No, the proper time is the one where both events happen at the same place. So right now, like for number one, the proper time is in the reference frame of 8.
Okay, so
Or not, or I'm mistaken, non-way.
We're talking about the proper. Okay, so yeah, if he was to.
But the proper length
I was trying to figure out
is 8 inches.
Yeah, so if he eats the steak, it takes him 10 minutes to eat the steak, and someone passes by, then the proper time would be, the proper time would be found in the reference frame where the steak is eaten and, where the steak is there and is gone in the same place, which would be in Monway's reference frame.
There's a Google Doc.
So 1A.
Reference.
Just edit it on your computer.
You don't even have to edit it on the computer. Just go to the Google Doc folder, Micah. It's already there in the Google Doc folder. No, what is wrong with you? Why would you ever not use Google Docs?
You know that writing things down helps you remember them. Yeah, writing things down helps you remember them a lot better than docs.
I'm not going to remember anyway.
Studies on this. Okay, in what frame is the proper length measured? So proper length is measured in the frame.
Wait, that's
is it?
personal email.
No,
it's not the same as proper time.
Proper length is measured in the frame of the steak. Because the steak is not.
Oh, when it's because it's moving. But it happens to be two same reference in this case.
No, it's the
They
same.
know a different reference frame. I'm on there.
Yeah, it would still be Monway because he's not moving.
Yeah, because let's consider the steak and Monway.
No.
But they're not the same reference frame.
They're not. Monway's frame and the steak's frame are not the same reference frame because in the steak's frame, the steak starts on there and it ends up in its stomach, right? So
Would that mean the steak was going
in
to...
its reference frame, but in Monway,
Would the steak be moving or would Monway be moving on
I'm like
so in the steak's reference frame, Monway is moving on.
Yes.
Okay.
In one, isn't that also the steak?
No, okay.
That means the steak is stationary at all times.
Oh, this
Proper time is measured by Monway, but proper length.
All right, come on. Let's just. It's like the steak or Monway. Let's not argue about it.
I don't think the steak is actually a choice.
It's a clear response.
Yes,
how is it not a choice?
It's a correct decision, but it's a case of
You could go in like the reference frame of milk to a bladder. It doesn't matter.
I don't think that's the right answer.
I don't think that's the right answer.
Someone please add that to the quotes page.
As measured by Monway,
Alright, fine, I'll second that.
more or less than 10 minutes to eat.
Less.
Since that's the proper time, proper time is always greater, right?
So proper time proper time is always the longest time.
So I have a question. Is steak a choice for the reference frame?
I mean, the steak's frame can be assumed to be the same as
Monway.
Monway's.
Oh, okay.
Okay, I told you. I told you.
And all of you are like, no, it doesn't work like that.
It's okay. They can be in the same frame, and if you put either one, that's fine.
Okay.
It would be less with the left next one.
Alright, for B, I'm still gonna write the steak because that's more correct. There's no such thing.
As measured
Yes,
by
they're actually
Someone's actually here. Who's the anonymous dinosaur?
It's shorter than 8
Why is what?
It's shorter than 8 weeks.
I bet you've heard that a lot.
Stop it. I bet you have too.
Shut up.
I think we all have, except for me.
Sure.
See, my head is all ready.
What are these names from? I feel like it has to be
Stop now.
Yes, I agree. Monway is eating a different steak.
Wait, is C less? Because isn't it like it's less time, it just looks slower?
What? Is C? Yes, C is less.
Okay, cool.
D is shorter.
Cool, I already got that. A, B. I hate myself.
And which frame is the proper time measured? Okay, Melchizor is the answer for B because he's not moving. I'm pretty sure I'm pronouncing all of these names wrong. And A, proper time, it would be Monway again.
For proper time?
Yes, because if the event is happening in both frames. Unless someone has a rebuttal for that.
What? Rebuttal. Alright, I'm gonna use Melvin for submitting this one. That's like I'm gonna submit one.
No, you don't have to say who's submitting it.
Oh, you don't?
That's why there's not a red asterisk.
Thanks.
Insert
How many?
Okay, well, according to himself? Wait, what?
Oh boy. Oh god. It's never good when you raise your hand.
So it says Monoway takes 10 minutes to eat 8-inch steak, and then you ask what reference frame to himself.
What reference frame? What?
Okay, it says Monoway takes 10 minutes to eat an 8-inch steak.
Right.
And Monoway
according to Melton.
right?
Yes.
And then it says, will Monoway take more or less minutes to eat the steak according to himself?
Yes. So the first one says according to Melkor.
Yeah.
Which is the first one? So that's Melkor's measurement, right? Melkor's using Melkor's reference frame.
Yes.
Monoway's reference frame. How much time will it take? That's
But Monoway's eating the thing, so it would still take...
No, it wouldn't. My God.
Okay, who's measuring the 10 minutes?
Melkor.
Melkor is taking... Okay, I thought Monoway was...
Is that like Melkor told you, like in the bus, in the subway or something? Like Melkor measured it to take, right? That's his observation.
Why?
Or maybe.
Who cares? Can we just do the problems?
No,
Why
I
does
need-
not matter?
I need to know...
I'm not talking about you.
Oh.
Oh my God. As being a girl. Yeah. As measured by Melkor, will Monoway take more or less than 10 minutes? It's That was the question. I'm still working on number 1. Y'all are.
What?
What?
Okay, wait, what are you at in number 1?
As number 1, I'm on C.
It's
It should
less.
be shorter or less.
Okay,
yeah.
just let me think, y'all.
Because it's less time, it just looks
I'm
slower.
trying to figure out why. Stop thinking. Why?
Drink the Kool-Aid.
Don't know why you won't be able to do the integrated.
Exactly.
Yeah.
I will not drink your tea.
What?
Sorry, I was thinking reference. Never mind.
I was
Drink the
making a
tea. Oh, I get
reference.
that.
I made a... Yeah, he gets the reference.
I made a reference to Jim Jones of Jamestown.
I made a reference to IMSA slideshow.
I got your reference.
Yeah.
I got your reference too. I got both of your references. As measured by Melkor, is this longer or shorter than 8 inches? It would
Do
be.
you not remember that slideshow?
It would be shorter.
Do not force him to drink your tea.
Okay, wait, in his reference, the steak is leaving here.
According to Monoway, it would be shorter.
Usually the spaceships, they all look the same length.
Yes, it would be shorter. Never mind.
Or if you look at the same spaceship.
Alright, so for 1, it's A, Monoway's frame, B, Monoway/the steak's frame, C, last E, shorter.
Yeah.
Here, you know what I'm gonna give you?
Monoway, Melkor, less shorter for number 2.
Okay, I'm gonna.
Oh, I thought you already had number 2 done.
Hey everyone, again, attention for a moment. Here's answer number 1, ready?
Yeah.
Okay, number 1, A, the answer is Monoway's frame would be the same as the steak's frame. B is Monoway's frame. C is more than 10 minutes. And D is shorter than 8 inches. Okay? So use that to make it work.
Why is it
You go ahead and keep working
It's
into
more
it
because
anyway.
time would slow down. It would look like he's moving slower.
Oh.
So even though technically it does take less, it would look like it took
Way
more.
better than Angel.
Oh, we're talking
You guys get what I mean?
Yeah.
But that's why I thought it was more. Because he just looks like he's
See,
moving
here's the
slower.
thing, observations and everything.
What?
You end up eating more steak then?
No, wait. After the shorter steak.
That doesn't have anything to do with it. It just means it's more condensed.
Oh, I'm sorry. Or does he eat less steak? Or does he eat the same amount?
He eats the same amount of steak.
It just the mass is.
Okay, so here's the thing. It actually takes less time, but as it's observed,
Actually, hold on. We got he actually eats more steak because mass
so that was why he
increases
had
according
Melkor's
to
reference
Mr.
frame.
Speeds.
Oh my god. You're right.
What happened? Wait, what?
He actually, mass increases at relativistic speeds. So technically he eats more steak. Because in the spaceship reference frame is moving by at relativistic speeds. So the steak therefore has more mass. So he eats more steak. That's so dumb.
That's so bad.
We're all.
Please.
Not really.
No. Wait, I need this to be disproved.
What?
I need him to correct me.
Okay, he need
Mass. Leave the mass out of it.
correcting on what?
Leave the mass out of it for 2 reasons. One, you don't need to know right now. 2, we will cover it later. And 3, the stuff that's on the internet and in a lot of books is wrong or at best misleading.
Wait, mass doesn't increase the
Just don't worry about it. Just don't worry
Micah,
about it.
shut up.
Problems. Oh my god.
I'm currently ahead of you. Thank you very much.
I'm done.
Yeah, you know what?
I'm trying to think. I'm distracted by all
Say
this.
that again.
That's not leave. What?
Gunner. Yes.
Yeah.
Just think of it as a gunner.
What?
Sorry, come here.
Eden.
Eden. I was like, the secret garden? Eden, yes.
That's how I remember your name. I imagine you on a ship and you on a garden.
And here I thought it was my amazing personality.
Plane. Fine.
Okay.
What?
I know that.
You see music violence?
What?
You prefer to be called tag?
That's something you'll have to figure out yourself.
Because I know you think
Okay, that wasn't me.
Actually, no.
Actually, it's the other way around.
Interesting.
That way, when someone's calling me in the hallway, I know whether or not to turn around.
you're a genius.
Him and Andy disagree a lot.
Alright, so you turn around to Eden.
About a lot of things.
Yeah.
See that?
Like, oh my word, you're a genius.
I know I am.
You only pay attention when it's someone you actually like.
And then the fact that Andy was there.
Yeah.
To be fair, though, I do have really bad hearing, so I'm probably not going to turn around the other way.
What's when you tell the people you don't want? You want to just tell someone.
What's your name?
My name is James. I'm James.
Y'all are like killing my
James
brain
T.
right
Kirk.
now because everyone is talking
Wait,
about
what is-
different things, and I'm trying to think about relative.
What is your name?
Yes.
Ethan. I'll try and remember that. We'll probably forget in 10 minutes.
A is ModPhysb.
Yep.
B is ModPhysb.
What?
For the same reason, if you think about it.
No.
Steaks.
I mean, for the same reason as number 1. C is less than 10 minutes, and D is longer than 8 inches.
Oh, I messed that up.
So you're getting more steak then.
Yeah, because we've already established that you're getting more steak. Which frame is the proper length measure?
A lot.
It should be ours.
But would it have more calories then?
Shut up!
It would have the same amount of
ratios
calories.
would
Actually,
remain the
no.
same.
Since the mass increased.
Can we not talk about mass? Oh my god.
So would the taste be different because of like how the mass changes?
Shut up for being an asshole.
Being a
Wait, you
mass.
thought you could say
astronauts
more rich so you like tasting better? No. Because the mass is relative, so he wouldn't actually notice
Right?
any change.
For C, it would be less.
Because he's not moving. But someone else, someone else would somehow weigh the steak while moving by at relativistic speeds, then they would notice a change in the mass. No, they wouldn't notice a change in the taste because the mass is relative. There's no actual mass gain because you can't actually gain mass for no reason.
Okay, when traveling at relativistic speed,
No,
does distance get longer or shorter?
shorter. Yeah,
Are you sure?
that's why it's linked to contract.
Oh yeah, okay, thank you.
And time dilation, it increases. Dilation is
I don't know anything. Can I just die?
Dilation? This is like the smaller one?
the dilation's increases.
Wait, have you done all of these? Or we've just been like yelling at each other?
We're not yelling at each other. I'm on number 4.
All I have to do is just not.
What?
What'd you get for 3A?
3A, I believe I got astronaut.
Okay, good. That's what I was gonna put down. But I was like, astronautalist.
Why not? It would take them a shorter amount. Oh, because time is moving. Okay. No, wait. In their reference frame, they're not moving.
No,
This is
so in our
I mean,
frame,
therefore,
astronauts
they
are going to
enter
start.
whichever
Well,
reference
the
frame
astronaut has a screen. The whole world.
Say those words again.
It's the whatever reference frame the two events happen at the same time, which would be their reference frame.
At the same place.
They're in the same place. Yeah.
time is measured between two events in a reference frame which the events are in the same place. So, if an astronaut launches and then goes into another place, the event has to happen in the same place according to the reference frame.
And the astronaut.
So can I just say it's the one where the subject of the question is not moving?
Yes. No. Well, kind of, yes, but no. In what frame?
But in general, that's probably going to be...
Most likely.
Okay. How about proper length?
I haven't read that.
Proper length, it's not moving. That's the
Okay.
actual definition.
Heck yes.
Do you observe? So yeah, proper length would be an R reference frame. Yes.
What?
No. Yes, proper length would be. Because in their reference frame, they're moving. In our reference frame, yes. This is true.
Where they start on the star.
That is spaceship moving rapidly towards Earth. So yeah, in their frame.
3A is the astronauts. B is hours, like on the Earth or wherever. C is less than 6 years, and D is less than 3 light years. Okay. I'll give you the answers in 4 if we get on the phone for a minute or two.
Number 4 is like
Oh wow, that's a lot of words.
bajillion questions.
Oh jeez.
I don't
Alright, yeah,
want...
if you think about it, because the astronauts have the proper time, that means they have the shortest time, which means it would take them less than it would take us, you know? And also when you think about it, because we have the proper length, and proper length is the longest, then it would appear to take them long because anyway. 4A, Georgina is in a spaceship moving rapidly relative to the Earth. Valentino is moving faster in the opposite direction.
Why are their names...
Their spaceship has the same length when in the same reference frame. So they're the same length when they're both still. And both of them have identical clocks.
Good for them.
To an observer on Earth, Georgina's clock will be moving at a slower rate because because her ship's moving slower and time gets shorter as it goes faster. Valentino's clock will be moving faster. Actually slower, yeah. Slower than the Earth's, yeah. Oh wait, hold on, we're not talking, Slower or faster than... To an observer on Earth, which spaceship will be longer? Georgina's. Why? Why? Because Georgina is moving slower. Because she's moving slower, and as you move faster, the distance gets shorter. Yes. So in Georgina's reference frame, Valentino's clock will be moving faster. I mean, it will be moving slower than hers.
Wait a minute. If you're not moving faster, does it to someone else? Never mind.
In Valentino's reference frame, Georgina's clock will be moving slower.
So slower.
Yeah, slower. For F, in Georgina's reference frame, which spaceship will be longer? Hers. And in Valentino's reference frame, yes. Alright, so, are you guys...
Alright, ladies and gentlemen, let me go ahead and give you the answers before I know not everyone's there.
I think we've got it.
Okay. Let me give you the answers. Fine. Okay, so A is slower, B is slower, C is Georgina's, D is slower, E is slower, F is Georgina's, and G is Valentino's.
Yes, I got them.
Okay, now listen up. Listen please. So, in preparation for tomorrow's quiz, what I recommend you do is whatever you check over slash you do if you prefer the homework, but make sure that you can do those problems easily and that you